this talk actually has 3 different purposes. First, what I'm going to talk about are decomposition or migration patterns to safely and effectively move from a monolithic system, single deployment unit, to a distributed architecture. That's the primary purpose of these. But also, there's 2 others. First, let's say that you have a legacy system that was written 5, 10, 15 years ago. I'm also, in this session, going to show you how to apply domain-driven design to a legacy system that was written even before domain-driven design even existed. And what that is actually domain-driven design from the bottoms up. The third piece that I'm going to show you is this. We've been talking a lot in the past 3 days, past 4 days, about software architecture. As a matter of fact, all of my sessions have had the context of a software architecture. What I'm going to show you also in this session is where they meet. The intersection of all this architecture stuff we've been talking about with the code that you write every day. We're going to see how these now finally come together and influence one another and interrelate. Oh, there's a 4th purpose of this session. I'm going to show you yet another way as a developer to think architecturally. Wow. Now, we have 2 days. Is that right? To do what? No. We have 57 minutes. All right. So those are all the different things you're going to learn through just going through all of these decomposition patterns. So decomposition, migration, it's the same thing. So when we have a legacy system, we think we're going to move that to microservices. And we start creating systems. Well, I can promise you, after almost now 11 years of doing this is what I primarily do, is greenfield or migrations to microservices. One thing I can promise you, there will be a lot of fire. Because it doesn't work well. And it hasn't worked well. It's hard. It's very hard. How do you decompose and tease apart monolithic systems? That's what I'm going to show you. Because there's a set of migration patterns, different patterns that we can apply to safely and effectively, with fairly low risk, move our applications to microservices. But again, keep in mind, it's like, oh, well, we're not doing that. That's okay, because the first 4 patterns, I'm going to show you how to create a really clean architecture out of a layered, or not layered, but a legacy system. So it starts out with our monolithic system. The first pattern is really to identify and size various components. This is all about taking inventory. Well, once we do this, then we do what's called flattening our components. This is really refining those architectural components, and I'll describe what all these mean, so that we have clean boundaries around all of them. Then we find the dependencies between them. This one's really fun. We have a good time with this particular pattern here. Now, once we find all of our dependencies and we're clear for takeoff, the next thing we're going to do then is to create component domains. We group components together into logical groupings that we can then physically represent. And we take each of those component domains and we create domain services. We move to a distributed architecture, separate deployment units for the same application. And then from there, we finally move to microservices. All right, well, let's take a look at each of these patterns. I want to apply a particular context because we will be looking at source code. And this is our problem. This is the SysOps squad. This is called an architecture kata. It's a problem. Kata is a Japanese word for form. It's what we use in martial arts and karate. It's a small, targeted exercise that leads to and used as building blocks for larger solutions. So this is our problem statement. So this is you, penultimate electronics, woohoo, and we're a large electronics giant. Well, when customers buy any kind of equipment, TVs, stereos, computers, home entertainment systems, they can also buy support plans. And if they have a problem or something breaks or they need help with installation, they can go to our website and create a problem ticket, and our customer-facing experts, our SysOp squad will come to your home or office and fix your problem for you. That's basically a problem ticket system. That's what we're going to kind of look at. So let's take a look at all of these patterns. The first one is to take our system or large service, whatever we're going to break apart, and start identifying what are called logical components. Now, a logical component, and I know component, we all have different definitions for it. An architecture component is a building block of the system. It's a piece of the system that does one thing. For example, maybe here, this is ticket assignment. So to assign a ticket to an expert in the field, that would be in a directory, SS for SysOp squad, /ticket/assign. Maybe it's a namespace, a package structure. So that I don't have to keep repeating all three of those words, I'm going to use a generic term called namespace. Now what that represents is the directory structure. I know it doesn't in C#, I know, and rarely does, but it's like a package structure in Java or a namespace in C#. It's where your code is. Formally, it's really just a directory structure. So SS ticket assign. All those class files you see right here all implement the assignment process to try to find an expert in the field. So this makes sense, doesn't it? Because these three classes notify our customers through texting. And as you can see, if we look at these components, why do we group code like this? Why are those three class files in that one directory there? Well, Mark, because they do one thing. They all do notification through SMS. Ah, exactly. That's our building block. That's a component. So that's the definition of how I'm going to define a component. Okay. That's important because that's the basis of all of these patterns, is that concept of that component. You see, it's kind of interesting. When we migrate applications to microservices, we do not move classes. We move components. And let me explain. So if we were going to create a service, let's use this one over here. This class and that class and this one would make a really nice service. So what do? I start pulling those class files out. That's a service. What else? Well, maybe these three plus that one, those would make a good service. So we start cherry picking all of those ones out. But wait, that one's associated with this one. This one instantiates that one instantiates over here. So those have to come with me. And we keep repeating this process, everybody. And it never, ever finishes. Have you ever been walking down the sidewalk on a hot sunny day? Of course, that's every day. Have you been walking down a sidewalk any day of the year here in Bengaluru, and all of a sudden you step down with your sandal and you and you feel that squishiness, and it's like, oh man, and you lift up your shoe and it was like you stepped in gum and it kind of just is all stringy and gooey. That's exactly what it's like if you start just identifying certain class files and start making services out of them, because they're all interconnected. And all of a sudden, we're duplicating classes everywhere. Let's go back to the concept of a component. Why is our source code grouped right here? Ticket.assign, SS/ticket/assign. Look at all those class files. Why do we group them? Well, because they're doing one thing. They're doing ticket assignment. Oh, wait a minute. What's the definition of a microservice? A single-purpose function, separately deployed, that does one thing really, really well. So do you see each component that we identify in our legacy system could possibly be a microservice? So when we move or make or extract code, we don't extract the class files, we extract components, entire directories, entire packages, namespaces. Okay, so now that we're clear on the component piece, this pattern right here really is about taking inventory. What do we have? So here's a chart that has some metrics that I find useful. Here's the name of the component, the logical name, so we could talk about it. But here's its namespace. Components are identified by their directory structures. Here's the number of statements. What we want to do is size a component. How do I know the size of a component? What do I denote as being too big or too small? I can't use the number of classes. You see, because each of us code differently. Some of us may like to make large classes with lots of methods because it's all very cohesive. Some of us say, no, I like a lot of small classes with very few methods. So that doesn't work. Lines of code. Some languages that works, but in others, like Java, it doesn't, because I do functional programming. So if I do map.filter, .reduce, .sort, is that on one line or 4 lines? I prefer it on 4. You prefer it on 1. My size is going to be 4 times bigger. No, it's not. It's doing the same thing. That's why I like to use statements. It's a little more accurate in terms of what the component is actually doing, because that's about the size. How much work is it doing? Now, I do still record the percentage here too, which is what percentage of the entire code base does that component represent? And finally, does it have any files? How many files in it? You'll see why that's important in a little bit. Okay, does anybody see, and here's SysOps Squad, does anybody see a possible problem here? Ooh, 33% of our code base is represented through one single component, reporting. Wow. I like to see every component less than 10%, or some sort of smaller metric, but within 1 to 2 standard deviations from each other. Here's 2 golden rules about architecture and code. The larger your components are, the less modular your system already is. And it's going to be much harder to break apart. The larger a component, generally, the more coupled it is to the rest of the system, because it contains a lot of the functionality everybody needs, but not all of it. So this is too big. Part of this pattern is basically decomposing that component. Reporting is 33%. What does it do? Oh, Mark, let us tell you, we create a lot of reports. I mean, we have ticketing reports, we have financial reports, we have expert reports, reports that tell us where the utilization of experts. We even have just a lot of shared code in there as well. Really? Why don't we make all of those components instead and just move our code down to those new directory structures, new packages, etc.? Well, that makes sense, because if we do, look what we can do here. Reporting 33%. That's a component. But we break it apart, and now nothing's greater than 10%. This is a much more modular system already. Okay, so that's really the first pattern. It's really about finding out what we have and starting to properly size everything. This gives us much better maintainability, less coupling between our components, better testability as well. Okay, so that's identifying and sizing components. Now, let's look at how code relates to architecture. Let's look at yet another way, which I didn't have time yesterday, That seemed like a long time ago that I did the architectural thinking keynote. That was only yesterday. About architectural thinking. I didn't have time to talk about a fourth aspect of it, and that's right here. Having having developers think like architects, keeping in mind the architecture. So here's what happens. When we look at components, we start getting these hills, component upon component upon component upon component, and it never stops. Let me show you what I mean. I'm going to take this view, and I'm going to push it down, boom, right on its side. And here is our first level directory, or namespace, app. On top of app, we have our SS. That defines it as sysop squad. Well, what's on top of that? Oh, a whole bunch of things, but also customer. What's on top of customer? That's notification. What's on top of notification? Letter. And it just keeps going on and on and on. I call these hills in applications. And what I have found in the 11 years I've been breaking apart systems, it's very, very hard to tease apart a monolith with a lot of hills. Where's the service here? Because if I pull out customer, I'm also pulling notification, letter, and SMS. If I pull off notification, I'm also pulling out the code for SMS, letter, and email. If I pull out customer, or just one big component, you see what I mean? It just keeps going on forever. That's what flattening is all about. Because right here, I don't see any components. And let me show you what I mean. So here's the area of code right here that represents all of our system. That part right there is customer. So that's our namespace, SS customer. But sitting on top of it happens to be billing. Notice how the hill is starting to form. Billing are those 8 classes. Now we also have, on top of that, notification. Those 8 classes. But we also have another namespace on top of that, which is SMS. Okay, wait. Do you see how the hill is forming? It's this big mountain up here. We could stop right here and say, wait, Mark, why did you create this notification? Why did you create this SMS namespace? I'll tell you why. Because I wrote those 3 classes that do all of our texting, our SMS notifications. And I have to maintain those. So I need to know where those are. So I put them in there. It's my own little space. And besides, all the other code and notification is really bad. And my code is really good. And so I want to separate it out from everybody else's horrible code. That's why I created a new namespace. Oh, I can't wait to retire. I really can't. Because I see this every day. Yes. But let's keep going, because it's like, well, then what are these 5 classes right there? Oh, that's other email, like other notification, letter, email. But what about these 4 classes at top right here? Oh, that's like customer information, profile, demographics, bill to, ship due, all that kind of stuff. This is a real application. How many possible services do you see here? How would you like to break this apart? No, thank you. It's too complex. This is what I mean about a hill, a mountain. So part of flattening is basically breaking down the mountain. So keep this picture in mind, because it's a disaster. So let's actually look at it from an IDE perspective. Okay. So notice the associations we have here. So this is what our IDE looks like. We see our corresponding namespaces or packages and the code that sits under them. These 4 right here, ss.customer, are these 4 classes right here. Notification are these 5, SMS are these 3, and then the billing match with these. Now I'm going to be manipulating our code over here, and I want you to kind of look over here and see what happens. So we can kind of see the whoop, there's like a little mountain going up. Okay. So the first thing we do in flattening is to say, I'm sorry, but actually, let me give some definitions. Okay. It's interesting. This, what I'm about to show you, somehow, for some reason, is highly controversial. There's a lot of people who do not like what I'm about to show you. But I do, especially for purposes of creating a nice, clean architecture that's maintainable, it's testable, deployable, and also the ability to migrate this fairly easily. So here's a couple of definitions for you. In our namespaces here, you'll notice I have notification. Anytime you extend a node, like to SMS, the prior one, notification here, becomes what's called a root namespace. Because I'm extending it, it makes more branches. So that becomes a root. That's the definition. Now here's the rule. No code shall exist in a root namespace. That's it. Just those two rules is all you need for this entire pattern. Definition of a root, I extended it, shouldn't have any code inside. And if I do extend it, I have to move that code. So, what is notification here? Notification's a root namespace. Why? Because it has code there, because I extended it. So how do I fix this? Right-click, refactor, move, SMS code back into notification. Now watch this. The SMS that I created because I just wanted my own little area? No. Right-click, refactor, watch over there, delete. Okay. Now, let's tackle customer. Because you notice customer's been extended. That namespace is extended to notification and billing. Therefore, it's a root. No code shall exist in a root namespace. I call that orphaned classes. These are orphans. Poor little fellas. They need a home. What do you mean they don't have a home? What's the component that these classes implement? There is none. Customer is not a component. If it was, it has subcomponents. Oh, now we're in trouble. So, what do? Well, what do those classes do? Oh, that's like customer profile information and stuff. Okay, so let's give them a home. Let's give those poor little fellas a home. So watch what I'm going to do. I'm going to create another component. Now watch what happens up here. I'm going to create, whoops, I have to be over here. There we go. So let's create it. Whoop, I went one too far. Okay, let me go back and do that again. Watch when I create that component. Watch what happens on the left-hand side. That's my right, your left. There we go, ready? Create it, and now I build up that hill. It's flattened, and I do a right-click refactor move of that code into profile. Now, I've satisfied all the rules. Now, I can't do a right-click delete on that namespace because all of a sudden every code goes away. But what is customer now? Is it a component in my system? No. It's a domain. It becomes a domain. So let me ask you now, how many possible services do you see in this particular legacy system? 3, notification, billing, and profile. Yeah, all nicely delineated. Okay, but let's do another couple of scenarios. Let's go back here. What would be another reason why you might say, Mark, those 4 classes there, which are right here, you can't move those. No. You can't move them. You would break everything. Why? Common code. Yes, exactly. They're shared code. You can't go moving those. All notification, billing, all the other stuff, those are our DTOs. Those are our customer utilities. You can't just go and move those. But they're still orphans. We need to give orphans a home. So we're going to create a component. Choose one word that's unique across all of your Git repos, all of your packages, all of your directories. Shared code, shared stuff. My name is Mark. Whatever unique directory you can. Okay, I'm going to just call it shared. Right-click, refactor, move. Have I broken any code? No. I've broken my fingers from continually doing right-click, refactor. But no, I haven't. That's what IDEs do. Now, how many services do you see here? 2. Notification and billing. Exactly. Well, but you've got code and shared. Right, that's shared code. What do we do in microservices with shared code? Probably shared library, shared service, depending on we're using inheritance or composition or inheritance. But yeah, usually a shared library. Isn't this cool? We're only on pattern number 2, and already we can see, I can tell whether this is feasible or not. Because if I do all of this whole pattern across all of my application, I can now write a very simple code walker, files.walk in Java, that says this. How many statements total in my system? 20,000. Okay. How many .shared directories exist? I count those up. I count all the code. We can even do the number, actually. I've got 57 components. 57 components. 23 of them end in .shared. What does that tell you? Half of my components, half of my code is possibly shared. So now I take it a level further. What's the percentage of all the code in a .shared directory? By the way, that meant that I would probably have about 23. Well, let's see, I said 57 and 23. Perfect. I'm going to have 25 services in microservices and 23 jar files. Feasible? Yeah, no. Let's actually calculate the number of statements through that. What percentage of statements are represented through all .shared namespaces? And it comes up with 12. Feasible? Yeah, we should keep going. I do this on another system, and it comes up with 84%. Microservices is not going to happen, everybody. 84% of our code happens to be all shared code. Yeah, we went crazy with code reuse. Yeah, so right here alone, we could actually determine whether it's feasible or not. But let's keep going. One more scenario. So what we saw on flattening is that this is a root, these are orphans, and we got to collapse it. No. Like, what? No. I don't want that code moved from .sms. Well, Mark, we went to GIDS, we saw this thing about flattening, and it really creates a clean architecture. It creates domains and subdomains and primary domains and all the thing from domain-driven design. I am the architect. Here's my architecture decision record. All SMS code shall reside in notification.sms. Approved. Great. Now what do we do? Sometimes it's not feasible to collapse things, but rather build it back up. So if we can't move SMS, what does that mean? These are orphans that need a home. Well, what do these 3 classes do right here? Oh, well, that's like email or letter. That's letter. Okay, so look what I just did. I created sms.letter, by the way. Let me back up. Watch on the left-hand side. Create a component. There it goes. Starts flattening it. Right-click, refactor, move. What about those other 2? Oh, those other 2 are about email. Okay, so watch what happens. I'm going to create another component. Notice it sits on top. Right-click, refactor, move. Interesting. Is notification a component anymore? No, it's a subdomain in my system. The components are SMS, letter, and email. Question for all of you, and you've seen this about, because Neil and I need to coordinate a little better. He's seen this question about 4 times in the conference. Should that be 1 service, 2 services, or 3 for notification? Because what's the service here? Oh yeah, we're back to that whole problem again, which you saw now how to answer that. Yeah, it could be 1 notification, it could be 2 electronic versus non-electronic or letter. It could be 3, all of the others. Okay, what this shows you is that not every component that we start identifying in our legacy application necessarily becomes a service. It may be groups of components that become a service. All right, so the point is this. Let me move that back up. We went in this second pattern here, from this mess right here. How many components? Nah, I don't know. And even if you did define them, it's not going to work. We went from this mess to here with fairly straightforward refactorings. 3 components, 3 possible services. Okay. Now that we flattened them, now we determine the component dependencies. Now, back about almost 7 years ago now, I was working at a client. It was my first day, and I was reporting directly to the CIO. And it was my first day. I walk in, and he said, "Hey, Mark," and his name was John, by the way. He said, "Hey, Mark, I know you're ready to get started and roll up your sleeves and help us migrate." But he said, before we kind of get involved in this, he said, "No one can answer me this one simple question. Is this level of effort that we're about to do a golf ball, a basketball, or an airliner? No one can tell me that." And I'm like, "Well, John, if you give me the credentials for the Git repo and gain access to it, I can tell you that answer by lunchtime with all the graphs and everything. But I'm curious about your sequence. A golf ball, a basketball, and an airliner." He's like, "Well, if you could tell me a sports ball that's as big as an airliner, I'll keep the same sequence." I guess we'll use airliner. It was a funny scenario because, well, I still use that same sequencing today. Okay, in this section right here, I'm going to teach you how to answer 3 core questions that you can answer in about 20 to 30 minutes. Is it even feasible to break apart this system? Number 2, what's the level of effort? And number 3, is this a refactoring of our code or a total rewrite of our code? Let me show you how you can go to work on Monday and within 20 to 30 minutes have that answer at hand. Okay. What we're talking about is not dependencies between source code, but dependencies between components. Thinking like an architect is seeing the system with all these components and correspondingly all the dependencies. Now, here's my point. When you move a legacy system to microservices, you do not move individual classes. You start moving components. So what I'm concerned about is how those components interact. You see this big component right here, this one. I don't care how big of a mess right now all those classes are. Oh, it's such a jumbled mess, I can't even read it. That's not my concern architecturally. What my concern is how those components all talk to one another. And what does that mean? It means a class file from one component, for example, ticket.maintenance, instantiates another class and another component, ticket.assign, and executes a method, invokes a method assign. That means that these 2 components, separate areas of source code, are talking to one another. Now, what I usually focus on here is incoming, because we're doing a migration. Outgoing is also important, but incoming is worse. Why? Incoming means all of you are dependent on me. And if I suddenly keel over and have a heart attack right here on the podium, well, the session's over, isn't it? Yeah. Outgoing means I'm dependent on you to listen to me. But if one of you gets up and walks out, I'm still going to speak. So we can make this faster by looking at afferent or incoming coupling. Let's do some analysis here. Let's take a look at this component. What's its incoming coupling level? How many components talk to it? And the answer, because I know it's hard to see for you up there, is 0, none. If I have a lot of these kind of components, well, it's kind of a golf ball. Small effort. Well, what about this one? Who's dependent on it? And let's walk through the dependencies. Well, this one is. Well, who's dependent on it? No one. If I've got a lot of those, I've got some dependencies. That's probably a basketball. Well, let's look at the one at the top here. Who's dependent on it? I want to use this one. Oh, no, I have to use this one. Who's dependent on it? This component right here. Another basketball. Oh, but wait. But who's dependent on it? It's all transitive. This one right here. Who's dependent on it? The component on the right and the component on the left. I think, any more incoming? One more, right here. Folks, that's half the application. It's all dependent on each other. Golf ball, basketball, airliner. I go to John and I say, do you remember that sequence? Yeah. What kind of airliner did you mean? Was it like a small regional jet, or was it a huge Dreamliner, Trip 7? Because that's kind of the area we're in now. Okay. There are tools that can give you exactly this analysis. One of the older tools, which I'm going to be showing you some actual applications on, was X-ray. It was an Eclipse plugin. Another one, a sonar graph, not cube, sonar graph. These are tools, as a matter of fact, a lot of IDEs now give you these mappings, but just be careful. It's not classes we're looking at. It's components, namespaces, packages, directory structures in these tools. Well, let me show you some real snapshots from actual systems that I have migrated. This was the second application I ever migrated to microservices. And this is what it looked like. This is X-ray. Now, the boxes represent components, not classes. The lines between them, as you can see, there's one very faint one right here, represent the dependencies. Wait, what lines? Exactly. Only one dependency exists. So, feasible? Oh yeah, this is a great candidate to break apart. What do you think of the level of effort? Golf ball, basketball, or airliner? It's a golf ball. Refactor or rewrite? Refactor. We're going to move around a lot of code. And so that was. It was a very, very straightforward project. Okay, this was another application I migrated, and something you will usually see. Oh, now we see the lines you're talking about. The thicker the line, the more dependencies. You can hover over that and see exactly the number of classes talking to one another. So, feasible? Maybe. What's the level of effort? Golf ball, basketball, or airliner? Airliner. We are burning jet fuel, everybody, on this migration. Is this a refactor or a rewrite? Largely a rewrite, and it was. This was a 2-year migration effort. Most of the code was rewritten. Why? Because we had all these dependencies down here, over here, up there. So let's try a little thought experiment. Okay. Let's pretend we're all fighter pilots. Okay, how cool would that be? That's what I wanted to be when I was a kid. When I grow up, I want to be a fighter pilot. But I have corrective vision. I'm wearing contact lenses right now. And when I was growing up, you couldn't be a fighter pilot if you didn't have perfect vision. So I went into IT. Okay. But let's pretend we're all fighter pilots. Okay, we're in our briefing room. I'm showing you where the enemy is, and we're at war, and all of us scramble to our jets and take off. Well, where's the enemy? Where are they? How do I know where they are? What do I use? Radar. Yes, exactly. Without radar, all of you would be blown out of the air within minutes. Radar's how we find our enemy. Folks, everyone, this is your radar. When you take and try to break apart and move a legacy application to microservices, there's enemy out there ready to blow you out of the sky. That's your radar. That's how you determine, what am I looking at here? What's the future here? Because if you just started to migrate, that's what your service dependency graph would look like. Now, the specific project I was on with this, the developer I was working with just loved this stuff. I mean, we were using this, we were using Code City, all these great visualization tools. And he said, hey, can we run this on our back-end settlement system? And I said, yeah, let's do that. So we ran X-ray against the back-end settlement system. And this is the actual screenshot. Now, this is actually not an application. This is a ball of yarn in which I'm going to knit all of you a sweater in the next 19 minutes. Yes. If you see this, run in the opposite direction, because this will never, ever, ever be migrated. Yeah. Folks, these tools are open source. They're available to you. Download these, run these against your application. This is your radar. Now, in most cases, you will see stuff that looks like this. And of course, let me just give you a quick 20-second thing about how we fix this part. That component had one particular interface. It had all the behavior that was modeled by about, I don't know, it was 30 or 40 other similar components. And so the developers said, why create another interface? Let's just reuse this one because it's all the same. It's the same pattern, it's the same interface. So that one interface was reused in all the other components. All we did to remove a lot of that dependency was take that common interface, that reused interface, which should not have been, and we made interfaces for all the other 25, 30 different components. Boom! The line got thinner. Yeah, that's the kind of analysis and refactoring we do. Okay, so now that we can say, yes, let's move forward, we can see exactly what happens, except that don't just run. Just simply drop everything and pretend there's a fire. Just run. Okay, now let's take a look at how to form those domains. Because now, think about it, we've flattened, we've got nice components everywhere. Now we do domain-driven design backwards and now create domains. For example, these 4 components that are now fully delineated represent everything about ticketing. It becomes a domain. And we manifest, represent that domain through the namespace, which equates to the directory. Well, do you see a problem here? I do. It contains maintenance, assign, routing, and customer.newTicket. You see, when we identify a domain, even through domain-driven design, going backwards, or the right way, what we want to do is delineate, physically manifest that domain through the namespace. Right-click, refactor, rename. Actually, this one's right-click, rename. Yep. There we go, ss.ticket.create. Now notice what we're doing in this. The second node contains our domain. If this is a layered architecture, it would be the subdomain because the layer becomes the domain, unfortunately. Here, that's all our customer stuff. Notice, notification support plan were put somewhere else. Because when you create namespaces or package structures or directories, do you really pay attention to the names of those? Sometimes. Maybe. No. So this involves a lot of right-click renames to be able to align all of our namespaces, all of our directories associated with each domain. And look what happens. Now we have 4 domains in our ticketing system. Ticketing, customer, knowledge base, and survey. Okay, and that's the idea of that. Now, at this point in time, let me go backwards 1. We have done domain-driven design from the bottoms up with simple, straightforward refactorings. We didn't involve the business. No, we're just doing technical refactorings here. And look what we have here, a clean architecture, something that's highly maintainable, better testability, less deployment risk. I can make changes faster, higher agility. What I'm pointing to is the fact that there's a lot of business value associated with just doing these first 4 steps. Okay. It's also showing you how to see your code as an architect. Every time you create a namespace or a package structure or a directory, you are creating a component. That's architecture. That's the structure of your code. All right, are you ready? Because now it gets exciting. Okay. The next step, once we've got the component domains, is to now extract them. I did my first talk on Wednesday morning was modularity versus granularity. And I talked about these two techniques, tactical forking and what we're looking at here, component-based decomposition patterns. Remember, component-based decomposition is about extraction. And that's exactly what we're going to do. So here's what we do. We take all of our domains, identify those, and we have one more refactoring. Right-click, refactor, move to another workspace. And that workspace now represents that domain. I've got a survey workspace, or project, whichever IDE you're using. I've got a survey, a ticket, and a customer. And now I deploy each of those workspaces, that code, as a separately deployed artifact, a separate assembly, a separate EAR file, a separate WAR file. You could do this for UI as well. And as a matter of fact, now I have a distributed architecture. Notice I haven't touched the user interface. I did that on purpose. All we've done is we've broken apart our core functionality in this legacy system into 4 separately deployed services. We haven't touched the data yet either. This is called service-based architecture. It's an architecture pattern we described in the Fundamentals of Software Architecture book. Okay, so that's where we are in our journey. This is the place where I now start doing exactly the same patterns on the user interface, breaking that apart into domains and subdomains, and possibly micro front ends. You see, I've done both. I've broken apart user interfaces first, back-end functionality and components first, and I have found through experience it's much easier to identify the back-end components first, create services, because now I have defined domains that help me see those groupings of UI functionality, screens, workflows, behaviors. Okay. Dependencies between domains is when a workflow crosses multiple screens. There we go. All right. Are you ready now for the exciting part? Because now we create those domains, and the next step is now to move to microservices. Okay. So this happens to be a secret sauce. This is my secret of my success. And that is this. Regardless if you're doing a migration, regardless if you're doing greenfield, move here first. Identify those domains. Create these very coarse-grained domain services. All of ticketing functionality is in one class. And I'll show you why. Because moving from where we're at now over to microservices is hard. I think we can agree there's probably a little bit of complexity in what we did. But folks, all we were doing is wearing out our right mouse button. Right-click, refactor, right-click, refactor. That's, you'll dream right-click refactors. But moving now to microservices is exactly like doing a steeplechase. Now, a steeplechase is where you race horses really fast across 8-foot-high barriers. At the point we're at now, to microservices, is a steeplechase. How many of you have ever done a steeplechase? Uh-oh. How many of you have ridden a horse recently? Okay, so you won't die. You won't die. If we're about to embark on a steeplechase, you haven't done one before, guess what's going to happen? You will fall off that horse, and you will get hurt. This is the pain that most teams are currently experiencing moving to microservices. That poor horse. Ouch. Wow, that's got to hurt. Well, if it is true, which it is, that where we're at now, to go to microservices is a steeplechase, and we don't want to get hurt or killed, you guys will be fine. Maybe. Doesn't it make sense to first learn? Doesn't it make sense to first learn how to ride a horse? Of course, if you've never ridden one, I should probably learn how to ride a horse first if I'm going to do a steeplechase. Yeah, it doesn't. And once we've mastered this, doesn't it make sense then to learn how to ride a horse really, really fast? Yeah. Race horses, and then, and only then, once we've mastered this, then we attempt that really hard steeplechase. Yes, of course, exactly. Mark, what in the world are you talking about? I mean, you had us there with the association of code and the intersection of architecture and how to represent code in architecture and the structure, but you're talking about horses now. I have no idea what you're doing. Let's equate it to microservices, because this is where we're at right exactly now. We're at the point where the clicker just is not working anymore. That's where we're at. Okay, this is where we're at right now. Okay, that wasn't bad, was it? I mean, we looked at a journey in the past 50 minutes of all these refactorings to clean up our code. Oh, no. We looked at source code refactorings to clean up our architecture. That's what we did. That's what we did. That is a solid, clean architecture that we just created. Learning how to ride a horse is now knowing what portions to change when. I mean, learning how to ride a horse is now kind of repairing some of those relationships with your testers, because likely in microservices, they'll be on your same team. It's starting to think about DevOps, to start to think about operational automation, Kubernetes, all that stuff, trying to play around with some of those things. That's the time to do it. Okay. That's learning how to ride a horse. Get here first. This is your first stop. Now, let's ride a horse fast. Learning how to ride a horse fast is knowing which portions to change when. So here's a service. This is our admin or administration service. This service does all the admin work, maintains name value pairs, users, different entities we have. There's 40 different kinds of operations, so probably 40 microservices and one user. Okay, let me give you another hint. This code hasn't changed in 9 months. It's really stable. Door number 2 is customer. Now, this is all the customer-facing part of our system here. Don't forget, these are domains. So here, there's 2,000 operations. Likely, this will be close to probably 2,000 microservices. There's 2,000 concurrent users. And also, let me give you another hint. This code changes all the time. Constant change to fix and repair things and add new features. We're learning how to ride a horse fast. Which would you rather tackle first? Admin or customer? Show of hands for admin. Yeah, obviously, yes. Wait a minute. Show of hands for customer. 1, 2. How's your resume? Oh, I got it. Agile. Bring the pain forward. The code is volatile. It changes all the time. Admin. Why admin? Why is admin the logical choice here? Yeah, you're learning. It's low risk, isn't it? If I mess things up, it's only admin. There's one user. It doesn't mean much. Yeah, we could practice on admin, learn, and then apply all those lessons learned to customer. Well, congratulations. If I had a book to give away, you would have one, because you two were correct. The correct answer here is customer. That is the correct answer. Why? Well, with admin, you get one benefit, don't you? Learnability. For a lifetime of pain and misery, trying to break apart admin data and maintaining 40 separate microservices when there's no use whatsoever for those. Let's go back to Wednesday morning, for those of you who were in my session, modularity. What were the core 5 drivers to move to microservices? Let's see. Maintainability. Do we need maintainability in admin? No. Do we need it for customer? Yeah. Testability. That was another driver we talked about. Do we need that for admin? No. We need it for customer. How about deployability? No, Mark, the code doesn't change. We don't need to worry about maintainability, testability, and deployability. We do in customer. What were the other two? Does anybody remember? Scalability. Yes. Does admin need to scale? No, there's one user. Does customer need to scale? Oh, yes. And the final one was fault tolerance. Do we need fault tolerance for admin? No, we've already got fault tolerance because if admin breaks, we don't break customer anymore. So we're already halfway there. Do we need fault tolerance for customer? Yes, we do. That's the one that we should break apart. So congratulations. Now, that was a trick question because 95% of all people say, well, obviously admin. But we learned a valuable lesson. Why? Because of learnability. What's the trade-off? No other benefit whatsoever. Here is the point. Oh, wait. We haven't done a steeplechase yet, have we? Do you notice, where's the database? It's still monolithic. The steeplechase, everybody, is migrating the database. Here's the valuable lesson learned here. Ready? Not every portion of an application has to be microservices. Greenfield or migration. We say this next system is going to be microservices. Okay, let's move here to domains and deploy those domains. Learn about it, analyze it, and only then migrate those domain services to microservices if we need to. And you now all understand the 5 core drivers to rationalize that pain and that misery. 30% of all projects I have done in the past 11 years, migration or greenfield to microservices, have ended up at service-based architecture. Maybe it's too hard to split up the data. Maybe we've got too much semantic coupling. Yeah, this was not very expensive. Microservices is. Okay, and there you have it. Those are the patterns of decomposition, and it's pretty cool. This is what I use. I developed these patterns about 9 years ago out of a lot of pain and heartache and sleepless nights to say there's got to be a better way to do this. Slow, it is slow, controlled, iterative refactorings to safely clean up your legacy system and then be able to extract those domains and then from those domains, extract services. That, everyone, is my secret sauce. The recipe for my success. All right, and now all of you have this now. Yeah. Well, we're not migrating. Well, maybe you're not, but now you have another way of seeing your system through an architect's point of view. What components do you have in your system? How coupled are they? Do you have a lot of mountains? Do you have a lot of large components that maybe would be good to break up? That is business value. Better maintainability, testability, and agility. All right. Everybody, you've been such a wonderful, wonderful audience. I have had just a rewarding experience. Thank you so much. Thank you.